Hey everyone. Today we're going to tackle a classic Java puzzle, something that trips up a ton of people, from students in their first coding class all the way to developers in a job interview. We're talking about comparable versus comparator. It's a really core idea for getting good with Java, and I promise by the end of this, you'll see it's way simpler than it sounds.
Okay, so let's just dive right in. Java is pretty smart, right? You can give it a list of numbers, a list of names, and just tell it to sort, and boom, it works perfectly. But what happens when you create your own thing? Like a student object, or a product, or a car? How on earth is Java supposed to know what sorted even means for one of those? That's the exact problem we're going to solve today.
So let's kick things off with section 1 and really frame this, the sorting problem.
And this slide just lays it out perfectly. Over on the left, you've got an array of simple integers. Sorting that? No problem. Java has a built-in universal understanding of how numbers work. But then you look at the right. We've got our custom student objects. Now what? What's the correct order? Should we sort them alphabetically by name? Or maybe by their grade? Or what about by student ID? Without our help, Java is completely lost. It needs us to hand it a rulebook.
And that brings us to the very first tool we can use to write that rulebook. So for section 2, let's talk about comparable. The best way to think about this one is that it defines an object's natural order.
Now here's the absolute key idea for comparable. It builds the sorting logic directly into your class. You're basically deciding on its one single default way it should ever be sorted. For a bunch of strings, that natural order is alphabetical. For numbers, it's, numerical. For your student class, you get to decide what its most natural, most obvious order should be. So let's break down what that actually means. First, it gives you a single default sorting method. This basically becomes the object's built-in inherent order. Second, and this is a big one, you have to be able to get in there and actually change the source code of the class itself. The whole thing works because you add a special method called compare_to. And just as a little technical detail, it's part of the java.lang package, so it's always there. You don't even need to import it.
I love this way of thinking about it. It's an idea that was really highlighted by Dr. Sasson-Azizian, and it just makes so much sense. When you implement comparable, it's like you're giving your object a kind of self-awareness. It just knows where it belongs. So if you tell a bunch of your comparable student objects to line up, they can do it themselves, because each one can look at another and know, okay, based on my name, I go before you, but after that other person. That sorting logic becomes part of their DNA.
All right, let's peek at some actual code. Now don't worry about every little detail, just notice two main things here. See at the top where it says implements comparable to student? That's step 1. That's us giving the class its sorting superpower. Then look inside that compare_to method. That's where we actually write the rule. In this case, the code is just saying sort us based on our names. And that's it. This class now has a natural order.
But what happens when that one natural order just isn't enough? Sorting by name is great, but what if the teacher needs a list sorted by the final grade? Or what if the front office needs a list sorted by student ID? We can't just keep changing the student class every single time. We need something way more flexible. And that brings us right to section 3, comparator, the flexible sorter.
And right here, this is the game-changing difference. A comparator is an external rulebook. It's totally separate, and honestly, this points to a really smart idea in software design, which is keeping your data separate from the logic that messes with it. A comparator lives in its own class, which means you can create as many different sorting rules as you want without ever touching the original student class.
So let's run through its key features. First, and this is huge, you can define multiple, totally different ways to sort. You can have one comparator for sorting by grade, another for sorting by ID, and heck, another for sorting by age. Second, you do not touch the original class's code. This is perfect for when you're using code from a library that you can't even change. The method it uses is called compare, and it works by looking at two objects from the outside and deciding which one comes first. And for the record, this one's found in the java.util package.
This is such a great analogy. It's so vivid. Picture it. The student objects are just kind of standing around. The comparator is like the gym teacher who walks in and yells, "Okay, today everyone lines up by height." The next day, a totally different teacher, a different comparator, could come in and say, "All right, today we're lining up alphabetically." The students themselves never change. It's the external rule maker that changes the game. And here's what that looks like in practice. We've created a totally new, separate class here called Sort by Grade. See how it says implements comparator student? This new class has one job, to hold the rules for sorting students by their grade.
The original student class is left completely untouched. This gives us amazing flexibility. We can create another class to sort by ID, another to sort by last name. You get the idea.
Okay, so we've met our two sorting specialists. Now it's time for the main event. Let's move on to section 4 and put them right next to each other in a head-to-head comparison. This is where it's all going to click.
This slide right here, this is your ultimate cheat sheet. Let's walk through it. First, purpose. Comparable is for a single natural order. Comparator is for multiple custom orders. Next, the method. Comparable uses compare to, where the object compares itself to another. Comparator uses compare, where it looks at two other objects from the outside. The modification. This is the big one to remember. Comparable forces you to modify the original class. Comparator is a totally separate class, so there's no modification needed. And finally, the package. Comparable is in java.lang. Comparator is in java.util.
So now you get the difference. The very last piece of the puzzle is knowing when to use which one in your own projects. So let's jump into our final section, choosing the right tool.
Honestly, it all just boils down to a super simple 2-question guide. First, ask yourself, does my object have one single really obvious natural way it should be sorted, like 99% of the time? For a movie object, that's probably by its title. If the answer is yes, and you can actually edit the class's code, then comparable is a great, clean way to go. But the second you think you might need to sort in multiple different ways, or if you're using a class that you can't change, the choice is made for you. You absolutely, 100%, need the power and flexibility of a comparator.
So, here's the real takeaway. You are now in complete control of how your data gets organized. You have the tools to bring a logical order to any kind of complex objects you can dream up, and that really just leaves us with one final thought. Now that you have this power to define order, what kind of complex data in your own projects can you finally get organized?